Hello, in this lesson we're going to solve some problems related to normal forces. Alright, so let's start with the problem from the last video about normal forces. We had the system here and, well, we have calculated the weight and the normal forces for this car that's not moving in an inclined plane, okay? And we want to calculate the friction force in each tire. Well, for the friction force, we still have this component of the weight that's pointing down the ramp. So we need a friction force to compensate this component here, so the car doesn't move. And this is the friction force, okay? So it's easy. We can just calculate the weight component in the x direction. It gives us negative 4,900 newtons pointing this direction. Okay, that's why we have this negative here. It means the total friction force needs to be 4,900 newtons, but in the opposite direction. Well, because the car has 4 tires, we can just divide this number for 4, and the friction force in each tire is 1,225 newtons. Let's move on to the next problem. Okay, for this problem, to better understand normal forces and how it can be misleading, let's calculate the normal forces in an elevator, alright? So I have this situation here, a man that weighs 100 kilograms in this elevator, and we want to calculate the normal force. So let's assume first that the elevator is not moving and there's no acceleration, alright? In this case, the net force is 0. Everything is in equilibrium, nothing is moving, so the net force is 0. We can start by calculating the weight of the person inside it, so it's the mass times the gravity acceleration, and it gives us negative 980 newtons pointing down, okay? So the normal force to compensate this force here, so the net force is 0, it's also 980 newtons but pointing up. Okay, now let's think about this situation here where the elevator starts to move up. So the initial velocity is 0, but now we have an acceleration of, let's say, 2 meters per second squared. Okay, so what should be the normal force in this situation when the elevator starts to move up? Well, we know that the net force now is not 0 anymore because the system is moving up. It's an accelerated system. So we can calculate the net force by multiplying the mass times the acceleration. So we have a net force actually of 200 newtons pointing up. In this case now, the normal force needs to compensate the weight force, but we have now the elevator moving up, so the force is actually greater. So for this situation, we have that the normal force is actually the opposite of the weight force. We have calculated already, that's 980, plus this extra force here that appeared because of the acceleration of the system. So now the normal force is actually 1,180 newtons is the weight component plus this force here that is resultant from the acceleration of the system. Okay, let's assume now that the elevator reach a constant speed of 2 meters per second squared after accelerating, so it stops accelerating. Okay, it starts with 0, it starts to accelerate, and then when the elevator is at 2 meters per second, it stops accelerating. So it's going up at this constant speed here. Okay, So what should be the normal force? Now we know that the net force is actually 0 because we have no acceleration anymore. So for this case, it's the same as the first case. So the normal force just needs to compensate the weight force that's pointing down. So look that the normal force here, even if the elevator is moving, but at a constant speed, is the same as it was not moving, right? Because what counts here actually is the acceleration, not the velocity itself. Alright, so now we want to stop the elevator, right? So we have an acceleration of -2 meters per second squared for the situation. We are slowing down until it reaches 0 meters per second. Okay, so we're stopping the elevator, so we need an acceleration in the opposite direction, alright? So for this case here, what should be the normal force? Well, now the net force is actually -200 newtons, okay? So the normal force should be the opposite of the weight, needs to compensate the weight, but in this case here, we also need the net force. And if we add these two forces, we have that the normal force is 780 newtons. So it's less than the weight force, okay? So be careful when you're solving a problem. So the normal force is not always the opposite of the weight only, okay? Sometimes it can be, sometimes it cannot. As we see in an accelerated system, we can change the normal forces because of the net force, right? And in an inclined plane, it also changes because the normal force is perpendicular to the plane of the load, okay? So be very careful when calculating the normal force. And well, these differences in the normal force pointing up is exactly what gives us that sensation when we start moving up in an elevator and then when you stop inside an elevator, okay? Hope you liked it, and see you next time.
Now that you watched this video, you're one step closer to achieving your academic goals. Well done! There's always more to learn, so check out our other videos and don't forget to subscribe.